Have you ever stared up at the moon and wondered about its origins? This celestial companion of Earth has captivated the human imagination for millennia. The moon's story begins over 4 billion years ago, a narrative woven from the fabric of the cosmos itself. As we gaze upon its cratered surface, we are looking at the scars of ancient cosmic events, silent witnesses to a time when the universe was much younger and more chaotic. Humanity's fascination with the moon is both a scientific endeavor and a poetic pursuit. Each discovery brings us closer to understanding not just the moon, but the broader universe and our place within it. One of the most compelling theories explaining the formation of the moon is the giant impact hypothesis. About 4.5 billion years ago, a Mars-sized body, often referred to as Theia, collided with the young Earth. This colossal impact ejected a significant amount of debris into orbit around Earth, which eventually coalesced to form the moon. The energy released by this impact had profound effects, potentially reshaping the geological and atmospheric structure of Earth itself. Despite its wide acceptance, the giant impact hypothesis is continuously refined as new data and technology become available. Besides the giant impact hypothesis, there are other theories that attempt to explain the moon's formation. The capture theory proposes that the moon was formed elsewhere in the solar system and was later captured by Earth's gravitational pull. Another theory, the fission theory, suggests that the moon spun out of the Earth itself when our planet was still a rapidly rotating ball of molten rock. Co-formation theories posit that the moon and Earth formed together from the primordial accretion disk of the solar system. Each of these theories highlights different aspects of the moon's mysterious past and underscores the complexity of celestial mechanics. While the giant impact remains the most accepted model, ongoing research and future lunar missions may provide further insights or even reveal new theories. The moon's origin story remains a dynamic field of study, reflecting the evolving nature of science. The moon's gravitational pull is most visibly manifest in the ebb and flow of the Earth's tides. These daily oscillations are a direct result of the gravitational forces exerted by both the moon and the sun on Earth's oceans. The moon, being closer to Earth, has a stronger influence, creating bulges in the ocean's surface, which we experience as high and low tides. Understanding the tidal forces gives us insight into the very nature of Earth-Moon interactions and helps us predict tidal patterns, which are vital for coastal management and environmental conservation. The rhythmic movement of tides mixes ocean waters, which helps circulate nutrients and supports the incredible biodiversity of our oceans. The study of tides also extends to other planetary bodies in our solar system, offering clues about their internal structures and the dynamics of their own moons. By understanding Earth's tides, we gain knowledge that transcends our own planet, reaching into the broader cosmic dance of celestial bodies. The moon's influence extends beyond the tides, impacting various biological rhythms and behaviors across the animal kingdom. For example, corals in tropical oceans often spawn en masse during specific phases of the moon, an event crucial for their survival and propagation. Many animals, particularly nocturnal species, adjust their behaviors based on the lunar cycle. Increased light during a full moon can lead to heightened activity levels in some species, while others might use the darker phases of the moon to conceal movements or enhance hunting prowess. Although the extent of the moon's impact on human behavior and physiology is still debated, some studies suggest subtle effects on sleep patterns and mood. Understanding these natural rhythms not only enriches our appreciation of nature, but also underscores the interconnectedness of Earth's biological systems and their celestial environment. The moon plays a crucial role in the biological and ecological dynamics of our planet, influencing life in profound and varied ways. The moon's presence might have been more than just a passive observer in the story of life on Earth. Some scientists propose that moonlight, by altering the nocturnal environment, could have driven certain evolutionary changes in both plants and animals. For instance, some night-blooming flowers synchronize their opening with specific phases of the moon, maximizing the chances of pollination by nocturnal insects. These evolutionary influences extend to the timing of various biological processes known as chronobiology. The moon's cycle impacts the internal clocks of many organisms, aligning their behaviors with lunar phases. Exploring these connections offers profound insights into the role of natural light sources in evolution and highlights the moon's potential role as a catalyst in the diversification of life on Earth. It invites us to consider how celestial bodies have had a direct hand in shaping the biological world as we know it. The moon has held a place of significance in human culture and mythology across the ages. From ancient deities like the Greek goddess Selene to the many lunar festivals celebrated around the world, the moon's phases and its enigmatic presence have inspired a rich tapestry of cultural expressions. Lunar folklore often sees the moon as a symbol of change and cyclicality, mirroring its phases and the ebb and flow of life. Lunar calendars have been used to track time and dictate agricultural activities, demonstrating the practical and spiritual significance of lunar cycles. Moreover, lunar mythology has often attributed mystical properties to the moon, influencing various artistic and literary works. Poets and writers have long been inspired by the moon's ethereal glow and its transformative power in literature, using it as a metaphor for internal change and enlightenment. The enduring allure of the moon in human culture reflects our perpetual quest for meaning and connection with the cosmos. While the moon's impact on tides and biological rhythms is well acknowledged, its influence permeates other aspects of our daily lives in more subtle ways. The moon affects the Earth's tilt and stability, contributing to a relatively stable climate over geological timescales. In modern times, the moon continues to inspire and shape human activities. Lunar cycles are considered in the planning of agricultural activities, and the cultural celebrations tied to the moon's phases contribute to community bonding and cultural diversity. The moon has a significant impact on scientific research and education, offering an accessible way to teach principles of physics and astronomy. The moon serves as a natural laboratory that helps illuminate fundamental scientific concepts for learners of all ages. It reminds us of the interconnectedness of all things, terrestrial and celestial, and challenges us to think broadly about our place in the cosmos and our responsibility to our home planet.